Our company develops an application called Yesplan, which is Seaside-based, and so is a web application. That means it consists of a lot of Smalltalk code, which is ran on a server, but also a lot of HTML, style sheets, and JavaScript code, which are handled by a user's web browser. We wanted to be able to write automated tests, which don't just test the Smalltalk code, but which test the interplay between all of those parts. And that's, of course, where each Parasol comes in. So Parasol allows me to write a little test like this, which when I run it is going to open a browser, go to the Yesplan login page, fill out a username and a password which is wrong. And then the test checks that the password field gets highlighted with an exclamation mark to inform the user that the password was wrong. So as you could see in the test run here, the test succeeded. I slowed down the test run a little bit for this video. I will show later that it goes a bit faster if you are doing it in development. So Parasol is implemented using some components from the Selenium project. Selenium offers a few different tools. The one which we use in Parasol is called WebDriver. WebDriver actually started as an entirely separate project from Selenium, which back then offered mostly Selenium Remote Control, or RC for short. But at some point, these two projects got merged, and WebDriver is now described as the successor to Selenium RC. It's available in a few different programming languages, the main one being Java. There has been some work before on using Selenium in Smalltalk, but as far as we know, these were all based on RC and not on WebDriver. One of these is the web tester framework, which you can still find on Quicksource, but I have the impression it's not actively supported anymore. Another project was presented at last year's ESUG. I did do some work then with Karsten at Camp Smalltalk to be able to put WebDriver instead of RC underneath his own framework that he developed on top of it. But what he presented in his presentation was still based on RC. So there are three key differences between RC and WebDriver. The first difference lies in the implementation, or how they control the browser. RC works through a combination of a proxy server, which wraps your website that you are testing and injects some JavaScript code into this page. The JavaScript code then communicates with your program or your test to receive and execute browser commands. WebDriver, on the other hand, works through a browser's native support for automation. For Firefox, that means a plugin. For Internet Explorer, that means it uses COM automation. Now, one advantage of this for WebDriver over RC is that it can overcome some limitations that RC has because of the JavaScript sandbox. In RC, it can be difficult to deal, or impossible to deal with some things like browser alerts, file uploads, or SSL, where the JavaScript sandbox comes in. A disadvantage, on the other hand, for WebDriver is that it only works with browsers for which a driver implementation is available. This isn't much of a problem, as most major browsers are supported, ranging from Chrome to Mobile Safari. But just to mention one which is not too obscure but unsupported, KDE's Conqueror has no driver implementation available. This can also be a problem if you want to use some older versions of these browsers, like for example Safari 4. There's no driver implementation for that. So, if you want to use the most recent versions, it's not much of a problem. So a second difference is that WebDriver aims to more closely emulate user interaction with the browser. This has some implications, one of which is on firing of JavaScript events and exactly which events gets fired or not. Another implication I will highlight on this slide is on clicking links. So the HTML snippet that you see at the top of the slide is a link to Wikipedia, but this link is not currently visible because of the styling that says display none. Now in RC, the Java code snippet that is going to click on this link is going to work. the browser is going to go to the Wikipedia homepage. In WebDriver, on the other hand, the equivalent code snippet is going to throw an exception, an element not visible exception. This is to stay close to the idea of mimicking user interaction, as it would also be impossible for a user to click on this invisible link. Now, this is important when you're writing tests, because this link could be, for example, part of a submenu on the page that is only shown if a parent menu item is first expanded. So you want your test code to also include code to expand the menu before it tries to click on the link. And this helps make sure that your test also tests that the menu actually works. So a third difference, and the last one, lies in the design of the API. The RC API in Java is very functional. It consists of a single monolithic class, which only has methods that take and return primitive objects, so strings, numbers, booleans, and arrays of those things. WebDriver aims to have a more object-oriented API. To illustrate the difference between those two, I've expanded the link click example from the previous slide here a little bit. And you can see that in the RC code, we deal with only one object in the variable Selenium. And if we want to click on the link, we send this object a click message, passing as argument a string that identifies the link on the page. In the WebDriver code, you can see that there are two objects involved. First, we have the driver object, which we ask to find an element on the page, passing it the identifier of the element. And this returns a second object, and it's that object that we then send the click message to click on the link. So it's a small example, but it shows that it's more object-oriented design. Now, to move from Java code to Smalltalk code, there's one more class I need to introduce. The WebDriver interface in Java has several implementations, such as the Firefox driver, Chrome driver, iPhone driver, and so on. One worth a quick mention in passing is the HTML unit driver, which implements a kind of windowless internal browser and is recommended by the Selenium developers as a kind of baseline browser to write tests against. But the class I want to introduce here is a remote WebDriver. You can think of a remote WebDriver object as a proxy for another WebDriver object that lives in another process, possibly on another machine. So this is useful if you want to, for example, from a Mac, run a test which uses Internet Explorer on another PC. Now what we offer then in each Parasol in Smalltalk is an equivalent class EP remote WebDriver, so not the other implementations of the WebDriver interface, just this one class, which communicates with the Java implementation in the Selenium standalone server, excuse me, which you will need to have running to be able to use Parasol. Now, I said you can think of a remote WebDriver object as a proxy. I should stress that this does not mean that the communication happens through a remote messaging protocol like Java RMI or SOAP. Actually, the standalone server exposes a HTTP-based interface in the REST style. So that means it's not modeled on objects that support certain messages, but it's modeled on HTTP resources that support one of the four main HTTP methods: get, put, post, delete. Now for you, those of you who are not that familiar with HTTP and REST, it would lead me a bit too far to explain that here. But the important corollary for Parasol is that this communication protocol, which is called the JSON wire protocol, the protocol does not impose a certain object-oriented design on top of it. So you would have been free to design things a little bit differently in Parasol than the Java implementation, but for the moment we decided to stick closely to the Java design. So most of the classes that you will find in Parasol are derived directly from a equivalent Java class, same for its methods. And these match mostly down to the name, with some provisions for Java's single keyword syntax and type overloading that it sometimes does. The reasons for doing it this way are firstly partly ignorance, because when we started the project we didn't really know how WebDriver worked, so it seemed easier to just follow the Java implementation. Second reason is that we felt this would make it easier to use the existing Java documentation and to translate Java examples to Smalltalk. So if you want to use Parasol, in most methods you will also find a comment that contains a link to the documentation on the equivalent Java method for this method. So one example that's shown here is for the getPageSource method, which is interesting to look at the documentation there, because it explains for which browsers or not you get the original source that was requested by the browser, or the source after it has been modified by any JavaScript running on the page. If you want to learn about Seaside and Parasol, the people at HPI wrote an interesting tutorial on using Seaside, and they've included a chapter on using Parasol to test Seaside applications. So that's quite interesting. If you already know about Seaside and you just want to use Parasol, you can find the project on the SqueakSource3 homepage. There's a wiki that explains a bit how to install it and where to find the standalone Selenium server. Finally, of course, if you want to join the project, there are some opportunities to do so. So some porting work has already been done. Our implementation that we use for Yesplan is in Faro. We also are working on a Gemstone implementation. But some other people have done some work on porting Parasol to Visualworks, which was done by Stefan Egermond, and also a port to Squeak by Tobias Papa. So if you want to use your favorite Smalltalk, it's up to you to do some porting. There's also some opportunity to complete the framework, because it has been implemented very much on a by-need basis. So we implemented the parts of the Java API which we needed in Yesplan. So one thing that's missing, for example, is that there are things to emulate touch actions for mobile Safari. So if you have an application, web application that is accessed on iPhone or Android, you would need to implement those things to be able to do things like the user touching the screen somewhere or whatever. It's quite easy to implement those things, of course, because you only need to map to the JSON wire protocol, which isn't very hard to do. Okay, I will move on to a bit more hands-on demonstration of Parasol. That's going to be a bit hard to do with the microphone. So I don't know if you can hear me if I don't use it at all.
Louder, please.
Okay. Let me first get set up. Okay, thanks. Going to put on synchronized modes. Okay, that's better. Okay, like I said, to be able to use Parasol, you need to have the standalone Selenium server running. So I'm going to start that now. I have it in a folder here. There's also another binary, Chrome driver, which you need if you want to use Chrome. So we just tell Java to start. We just tell Java to start the code that is in this jar file. So here in the terminal window, you get quite a lot of output from the driver, which can be useful for debugging. One more thing which I should start, but this is not really needed for Parasol, it's needed for Yesplan, is a goods database server. And let me open the image with some codes. That's a little bit too big maybe. Okay. So, to give an example, I'm going to first implement a small Seaside test component. So what it is going to do, I'm going to implement the rendering methods to show a link. Okay. And if you click this link, we are going to set a variable should show. And this variable is going to control some extra HTML that is going to appear on the page. Like this. So, hello, ESUG. One more thing, of course, is to initialize the variable. Okay, that's it for the component. Now let's take a look at implementing the test case on this component. So the class in Parasol is called AP WebDriver test case, I think. No, it's not. It is, okay. Now, if we take a look at the framework, so we inherit from the class BP WebDriver test case. There are some methods here. There is only one, which is a subclass responsibility, which is this method, component class, which you use to tell the test case which is the Seaside component that you want to test. So I'm just going to implement that in my subclass to say that the component is, of course, demo component. And then we'll need a test demo, and the only thing I'm going to put here for the moment is test demo. So let me run that. It takes a while to start Firefox sometimes. So the code I implemented in the component doesn't do a lot. It just has this link. If I click it, it shows hello ESUG. So I'm going to write a little test for that, which just tests that if I click the link, that the text gets shown. Yeah, this sometimes happens if you put halts there. So I'm just going to ask the driver object, which is already instantiated by the setup in this test case, to get the link element on the page, which I'm going to click, and then I will check that the paragraph element appears on the page. So its text should be hello ESUG. I'm going to leave in a halt here so we can step through the test case. So I have a debugger here, let's go into it. And step through this part where let me first execute and inspect this. So you see what I get is a EP web element. It doesn't have a lot of instance variables. I will proceed through the test, click on the link. So if we look at the browser, we see that indeed the link has been clicked and the paragraph appeared on the page. So if I continue, the test should work. And indeed it succeeded. Now, one thing that I want to show in this demo is a difference between explicit waiting for elements to appear and implicit waiting. I'm going to explain that in a moment. So let me put a delay here to 3 seconds. Yeah, that should be all right. So if I execute the test now with the delay there, what's going to happen is when the link is clicked, it takes a while to load the page. What you will see is that the test still works because WebDriver waits for page loads to complete. Now, the reason I'm explaining that is because in Yesplan we do not rely that much on this page load mechanism that Seaside has. So what you see here, the way the component is implemented now, if I click the link, you can see that the URL here changes. If I click it again, the key here changes again. So this is every time a new page load that happens. But in Yesplan we use a lot of Ajax and jQuery where a page is more dynamically changed instead of loading a new page. So to emulate that, I'm going to change the implementation of the demo component. I'm going to retype it. So I'm going to on-click, it's not on-click like that. So I'm going to write some code when you click the link, some extra paragraph gets added to the page in the same way as before. Instead, now it happens dynamically without doing another page load. Okay. There's one more thing I should not forget to do, and I'm just going to copy that from my canned demo, which is to make sure that the jQuery JavaScript library is loaded on the page. One more thing I'm going to put in is to build in a delay as before, so that it takes some time after you click the link for the page to get updated. So that's the timeout part here. Now if I run this test, it's going to not work. So I get a debugger which tells me that this part of the code here fails because the element could not be found. So I get a BP no such element exception. Now by this time, if I run this code, I actually do get an element, because by now of course the time for waiting after clicking the link has elapsed and the page has already changed. So there are two things I can do in this case. One is I can build in a explicit delay here to wait for 3 or maybe that's to be make sure 4 seconds. But another mechanism that WebDriver offers is you can configure an implicit waiting parameter, which means that if I do something like this, I will tell the driver object to configure the implicit waiting timeout to a certain duration for like 10 seconds. And what that does is, if you execute code like this part here to find an element on the page, and the driver does not find a matching element, it will try again a few times until the timeout that I have configured has elapsed. So this is quite useful for applications like Yesplan, where we use a lot of stuff like this, so dynamic changing of the page, so that you don't have to write a delay everywhere in your tests when you are waiting for JavaScript code to update the page. So let me just demonstrate again that it works, or at least I hope it does. So the test worked. That's mostly what I wanted to show in this demo. So if there are any questions, you can of course ask them now, or if you have any questions later, you can mail me at Kris@yesplan.de. So, any questions? Yeah?
Does it work with HTTPS?
Yes, it does. Sorry. Yeah, sure.
The test class hierarchy, is it part of Parasol, or is it something that you developed for your Selenium testing?
So, the hierarchy looks like this. So the test case, that's just a regular SUnit implementation. This is the part that's offered by the Parasol package. It's a little bit specific to Seaside. Actually, we should split it up into one where you can use the test case to just test any website, and one which forces you to implement this component class because it's for testing a Seaside app. So, yeah.
So the Parasol can be used for other web products also, like
Yeah, you should be able to do that. So the way it's described actually on the Selenium project homepage is that WebDriver is just a framework for automating web browsers, and writing tests for web applications is just one of the, or at least, well, the main application, but it's just one of them. And same thing goes for Parasol. You can use it to do any browser automation if you want to, but of course we use it to write tests. Yeah?
If I understand completely, or if I understand correctly, you're using the component class to construct the URL
Yeah.
the test will navigate to. That's easy if you have one component registered as a Seaside group component.
Yeah.
But what if you have a multi-page application? How do you address some component that's 5 pages away from the start page?
Well, you could write an individual test for just that component, but given that the idea here is that you test really a user interacting with your web application, what we do in Yesplan is we go through the full process. So every test always starts from the login page, it logs in to Yesplan, and it navigates to the part that it's going to test. So you don't have to do it, you could test individual components if you want to, but we think it's better to go through the whole process, make sure that everything works.
So, if I understand correctly, you have one test that starts with a component class,
Yeah.
and the whole test navigates to the component that you actually want to test.
Yeah.
Okay, I see.
Yeah.
Thank you.
Okay. Yeah, okay.
Okay, you said that the setup of the test is taking quite a while.
Yeah, starting Firefox takes a while. Chrome is a bit faster, I think. One thing I did do is I in Parasol there is some code to cache browser sessions from the WebDriver. So if you run multiple tests in sequence, they will try to use the same browser window. This doesn't always work for some other applications maybe that open more browser windows, but for Yesplan that works all right. So if you run multiple tests in sequence, you will see that it takes just like 1 or 2 seconds for Firefox to start, but then the other tests will reuse that same browser window. So you don't have as much of a delay there.
Can you give us some example of how many tests you are running and how much time it takes?
I know that our full test suite for Yesplan takes about 3 hours to run on our Jenkins server, but this includes like 20 or half an hour just to load all of the code, because it starts from scratch, so it takes a Faro image, it loads everything, so that's half an hour that goes to that. And then the remaining time, so the 2 hours and a half, is for running all the tests, but not all of these are web tests. I think we have in total about 3,000 tests, of which 500 use Parasol. I'm not sure exactly how long those take. I could take a look at it if you really want to know. But off the top of my head, I don't know. Yeah.
I'm wondering about the test fixture, the data that you provide for your tests. The way I look at it, you could run this from the same image in which the Seaside implementation of your server-side runs, but you could also run a separate image to really have some completely independent piece of code that does the testing, so that you don't access test data directly just by something you forgot. You might be tempted to ask the customer object if it's really called Joachim now. And you will probably want to avoid that. So I would try to run this in another image. But if that is the case, how do you define your test fixture, your test data?
Well, at the moment for Yesplan, we do just use one image that runs both the test code and the server code, so to speak, which is also useful if you want to debug tests. So if there's some does not understand in the server code, you can just debug it in the image. It should work, I guess, if you use 2 separate images. But it's also useful to be able in the tests to not just assert that something has appeared on the page, but also to be able to assert that the database is in a certain state after you did some operations in the web interface.
Okay, so in an ideal world, you would even probably mix both.
Yeah, you could.
Sometimes you want to test the data really and have access to it, and sometimes you probably want to have a
you
separate
could
process.
do that. Yeah.
But you're currently using it out of one image.
Yes. Yes.
That makes access to data easy, and you can define your data.
Yeah, indeed.
Do you have an idea how you could probably do that in a separate image?
It should be very easy. I mean, you just set up a server which offers your web application. So just one image to do that, and then the tests just browse to this web page offered by that image. The only thing you might need to want to do is to have some kind of reset command that you can send to the server to reset the database, or because otherwise the tests are going to interfere with each other. Or one way you could get around that is not to test on data that is present in the database, but to test on how the data changes. So you would have to take that into account.
Thank you.
Anyone else? Okay, thank you for listening then.
De lunch Normally they should be in the process of installing everything, so I will look around because it's not clear yet. So normally, from what I understood, this is that there will be a place where you can take kind of a buffet, and then there is a big room on the other side. There are two big rooms on the other side where you can just sit and discuss and things like that. And normally I saw the guy that was coming in, so they should be preparing.